Hey students, this video is going to go over double replacement product predictions. So double replacement reactions are where we have two ionic compounds on the reactant side, and they're going to form two ionic compounds on the product side. Now, an important thing to know is that we have to make a solid, a liquid, or a gas in order for the reaction to happen. If we make two aqueous products, there is no reaction. Okay, so it's really important to review those solubility rules at the bottom of the page and check your states of matter for your products to make sure that the double replacement reaction occurs. If there's no reaction, there's no need to balance the reaction, so it's really important. So in order to review some ionic compounds, if we look at number 1, I just want to remind you that an ionic compound always involves a metal ion in the front, and it's going to involve a non-metal anion, a negative ion, in the back. Okay? So when we make our two new products, we have to include a cation and an anion. And you need to remember their charges and use their charges to drop and swap again. You do not take their subscripts from the reactant side when you're making the products over on the right-hand side of the reaction. So when we make our products, we're going to take our two outside ions together so that we can have a positive and a negative ion, and we're going to make our two inside ions together. So when you make your products, remember, you want to get your charges from the periodic table or the polyatomic ion list. You want to drop and swap again, so that way you can have the correct ratio to balance out your charges. And then you're going to check your solubility chart. Also, when you write your ionic compounds, remember that the metal gets written first, or the positive ion, and the non-metal is going to get written second. That's your negative ion. Okay, so metal, positive ion first, non-metal, negative ion second. So when we look at example 1 here, we have zinc and carbonate. So remember, zinc has a +2 charge, and carbonate has a -2 charge. So those 2's are going to cancel out. So one of our products is going to be ZnCO3. And we'll check our solubility chart down here at the bottom of our page. Remember, we're checking our anions, so we're looking for CO3. Here it is, carbonates. They're usually insoluble, which remember means solid, except ammonium or alkali metals, which zinc is not. So zinc carbonate is going to be a solid. And our other product is going to have Cl and Na, but remember, our metal is always going to get written first. So Na's charge from the periodic table is +1. Cl's charge is -1, so our formula is NaCl. And that state of matter, when we look here, there's chlorine. Chlorine is right here, usually soluble, usually aqueous. Na is not an exception, so NaCl is going to be aqueous. After you write your products, you would then go balance your reaction. So I have 1 zinc, I have 1 zinc, I have 2 chlorines on this side, so I need 2 chlorines on this side, so I'm going to put a 2 here. I've got 2 Nas, now I have 2 Nas because I put my 2 coefficient here, and then I've got 1 carbonate, and I have 1 carbonate, so I am balanced. Let's look at example 2. First I'm going to highlight my ions. What's the positive ion in CrCl2? That's the chromium. What's my positive ion in the potassium iodide? That's the K. And then I'm going to go ahead and highlight my anions, my negative ions. So I've got Cl and I. So remember, I've got to have a positive and a negative ion in each of these examples, or each of my products. So my outside ions are going to come together, my inside ions are going to come together. So I've got to get my charges. So chromium in this particular case, because chromium is a transition metal, chromium has a +2 charge, and it's going to bond with iodine, which has a -1 charge. So that's going to be Cr I2. My solubility chart down here says that iodides are usually soluble except when it's bonded to silver, lead, or mercury. So in this case, that is soluble. So it's aqueous. And then our other one is going to be KCl. So K plus 1 and Cl minus 1. So when I drop and swap, that's going to be KCl. And when I look at my solubility rules down here, chlorines, usually soluble, K is not an exception, so this is aqueous. So that means that this reaction will not occur. No reaction, because I made two aqueous products. Let's take a look at number 3. Let me highlight my metal ions first. The positive ions always come first. And then let me highlight those anions, the negative ions, OH and CO4. Alright, so remember, these two outside ions are going to come together. These two inside ions are going to come together. So, my first one is going to have Na and SO4. Na has a +1 charge. Sulfate, if you forget the charge, you can look on your polyatomic ion list. Sulfate has a charge of -2. So when I drop and swap, that formula is going to be Na2SO4. When I look at my solubility rules down here, SO4 is usually soluble, and Na is not an exception, so that means this is aqueous. And then my other product is going to have OH and C, but remember the C was going to come first. Now we have to figure out what the charge is on this copper in order to drop and swap. Well, sulfate we know had a charge of -2. Why is there not a 2 here behind the copper? That's because the charges had to have canceled out. So the copper has to be a +2 charge, which means on the product side it's going to be +2. And it's bonding with OH, which is OH minus 1. I can check my polyatomic ion list to get that charge. So let's look at hydroxides down here all the way at the bottom. It says hydroxides are usually insoluble solids, and copper is not an exception, so that means this is going to be a solid. So when I drop and swap, don't forget to put that OH in parentheses, because I'm dropping a 2 behind that state of that polyatomic ion, and it's a solid. So I'm going to have to balance this reaction. On the reactant side, I have 1 Na. On the product side, I have 2 NAs. So I'm going to put a 2 here. I have 2 OH groups now. I have 2 OH groups. I have 1 copper. I have 1 copper. I have 1 sulfate. And I have 1 sulfate. So that reaction is balanced. Okay, now with number 4 here, let me go ahead and highlight my ions. So I've got K. Now in this case, when H is in front, it's acting as a positive ion. It's actually an acid, we just haven't gotten to acids yet. And then I've got OH and I. So, again, my 2 outside ions are going to come together to make a compound. My 2 inside ions are going to come together. So K has a charge of +1. And I has a charge of -1, so that formula is going to be Ki. When we check our solubility chart, here's iodine, usually soluble. K is not an exception, so that is soluble, aqueous. Now, here's the thing. When OH and H come together, when these two things come together, H and OH, that makes water. Doesn't matter how many H's, like if there's a subscript on the H or if there's a subscript on the OH, if you're highlighting H and OH, it's going to make H2O. And H2O is a liquid unless I otherwise state. So let's go ahead and check our balancing. We have 1K, I have 1K, I have 1 O, I have 1 O, I have 2 H's, I have 2 H's, and I have 1 I, and 1 I, and that's balanced. So looking here at number 5, again, let me highlight my ions. Positive ions are going to be in yellow. My negative ions are going to be in pink. Notice every time I make an ionic compound, I always put a yellow with a pink because I have to have a positive and a negative. Don't ever put two metals together. Don't ever put two nonmetals together. And these two ions are going to come together. So, I'm going to have Hg and I. So Hg, in this case, has a charge of +2, because this 2 here came from the mercury, so I know it's +2. It's positive because it's a metal. Iodine has a charge of -1. So that formula, when I drop and swap, is going to be HgI2. Let's check our solubility chart. Iodine's usually aqueous, but here's mercury as an exception. So this is going to be solid. And then my other product is going to have the nitrate group and potassium, but the potassium has to get written first because the positive ion always gets written first. Nitrate, look on your polyatomic ion list. You can see the charge of nitrate is -1. And when I drop and swap, it just becomes KNO3. I check my solubility chart here. Nitrates up here near the top. Soluble always. No exceptions. So that's aqueous. Let me check my balancing. I have 1 mercury. I have 1 mercury. I have 2 nitrate groups, so I need to have 2 nitrate groups over here. I'll put a 2 coefficient here. I've got 1 potassium on the reactant side. Now I have 2 potassiums here, so I have to put a coefficient of a 2. Now I have 2 iodines, and I have 2 iodines. So this is balanced. I shall highlight my cations, positive ions, my negative ions here. So my outside ions are going to come together. My inside ions are going to come together. Remember, I've got to put my metal ions first, and I have to drop and swap. So even though this is not a metal, ammonium, it's a positive ion, so it needs to get written first. And it's going to bond with chlorine. And that's a -1. So this is going to become NH4Cl. Even though this has a 2 here on the reactant side, when I drop and swap again, there's no subscript on the Cl. Check my solubility chart. Oh wait, here's ammonium right here at the top. Ammoniums are always soluble, aqueous. Then my other product is going to have the sulfate group and barium. Which one of those two things has to get written first? The barium ion, because it's the positive ion. And then the sulfate, again, check your polyatomic ion list for those charges if you need to. It has a -2 charge. Those charges are going to cancel out, and so it's going to be written as BaSO4. Checking our solubility charts. Our sulfate groups are usually soluble, but if it's bonded with barium, it becomes solid. So this is solid. Let's balance. I've got 2 ammoniums, but on this side I only have 1 ammonium, 1 NH4 group, so I need a 2 here. I have 1 sulfate group, 1 SO4. I have 1 SO4 group here. I have 1 barium. I have 1 barium. I have 2 chlorines, and I have 2 chlorines. Now, if it's in words on the reactant side, I have to write the formulas first, and then on my reactants, and then get my products. So calcium has a charge of +2. Again, see how I'm getting those charges and I'm dropping and swapping. Chloride means that's just chlorine from the periodic table. So my first reactant, when I drop and swap, is going to be CaCl2, and that's aqueous because it tells me so. Then sodium is Na. It has a charge of +1. Carbonate is a polyatomic ion. So I check my list. It's CO3, -2. When I drop and swap, that is Na2CO3, aqueous. So let me see. I hope my highlighter doesn't make this bleed. And it sure does. So those are my cations. Those are my anions. It's a terrible choice to use red because it's hard to see. But my outside ions are going to come together. So Ca and CO3, let me jot it down over here so you can see those new charges and see how to drop and swap. So calcium is +2, carbonate is -2. Those charges are going to cancel out. So this is going to be CaCO3. When I check my solubility chart, here's carbonate, CO3 -2, insoluble solid, and it's bonded to calcium. It says calcium is not an exception because alkali metals are group B. So this is solid. Plus, I'm going to be bonding the chlorine and the sodium, but remember the sodium has to get written first because it's the positive ion. Chlorine's my negative ion, so when I drop and swap that becomes NaCl. And I can check my solubility charts. Here's chlorides, usually soluble. Sodium's not an exception, so this is aqueous. So when I balance, I've got a calcium, and I have 1 calcium. I have 2 chlorines on this side. I only have 1 chlorine on this side, so I have to put a coefficient of a 2 in front of there. I have 2 sodiums. I have 2 sodiums. I have 1 CO3 group, and I have 1 CO3 group, so I'm balanced. Number 8, last one, aqueous iron 3 sulfate. So iron 3, that Roman numeral 3 means the charge on the iron. Sulfate, check your polyatomic ion list. 8 means it's a polyatomic ion, SO4 -2. I drop and swap. So my first reactant is Fe2 SO43, and it says that's aqueous. And it's going to react with barium hydroxide. Barium is +2. Hydroxide is OH -1. That's a polyatomic ion. So when I drop and swap, it's BaOH2. It's aqueous, it tells me. So I'm not going to highlight it this time. I don't want to make it bleed. But my positive ion from here is going to bond with my outside ion, my negative ion over on this side. So iron and hydroxide are going to come together. I have to use the same charge on my iron. So iron has a +3 charge. Hydroxide is OH -1. So that's going to become FeOH3. Parentheses around that OH. Hydroxides are all the way at the bottom here. It says they're usually insoluble, which is solid. Iron is not an exception, so this is solid. Then my other product, I have my sulfate group and barium, but barium is going to get written first because it's the metal ion. Sulfate gets written second because it's the negative ion. Those 2's are going to cancel out. So I have BaSO4, and I check my sulfate group here. Sulfates are usually soluble, usually aqueous, but barium is an exception, so this one is also solid. So I balance. I've got 2 irons on this side. I only have 1 on this side, so I have to put a coefficient of a 2. I have 3 sulfate groups here. So I need 3 sulfate groups over on the product side by putting a 3 coefficient here. I have 1 barium on the reactant side. Now I have 3 bariums on the product side, so I put a coefficient of 3. I've got 3 times 2, 6 hydroxides. I have 2 times 3, 6 hydroxides. So I am balanced. So it's really important to do some practice with these double replacement reactions. Until you become proficient at this, write your ion charges, see how to drop and swap, make sure you have a metal and a nonmetal with each of your products, and then check your solubility chart to make sure that you have, you don't have, I should say, 2 aqueous products. And just let me know if you guys have any questions.